You were here early this morning, Sean.
Okay. Yeah, early morning. Wife had to work half hour earlier.
Okay, you need 59.
That was when I got here. It was actually about 10 minutes after I got here, but yeah. Alright, anyways, dilation. Like you said, making things bigger or smaller, right? What would the center of dilation be?
The point you're dilating it.
The point you're using to dilate. Yep. And then your scale factor.
How much it changes?
How much, right? Is it possible to have a fraction?
Yep.
What would a fraction do?
Make it smaller?
It'd make it smaller. A number bigger than 1 would make it
Bigger.
bigger. So if I have two triangles, okay, and in this case, my center of dilation would be here, okay, just because I know if I went on this line, this point ended up here, and so on, okay? Even if I do this for you, I say this is 4 units, and this is 13 units. Is there anything that's been done that tells you whether it's a reduction or an enlargement yet?
No.
No. When I say reduction, I mean that what's happening?
Making it smaller.
Making it smaller. When I say enlargement, I mean getting bigger. Okay? There's nothing notifying us which way we're going here. Now, if I do this, now it is it's an enlargement because I started here. This is my pre-image, and then I went to here with my A prime. That's my image, right? Okay. We just said this a second ago. What do you have to know? What has to be true about the scale factor for an enlargement? To make something bigger, scale factor has to be greater than 1. Okay, so for an enlargement, your scale factor K is going to be greater than 1. Okay, does that mean that it has to be a whole number?
No.
No, it could be 1.5, 1.2, could be anything, right? As long as it's bigger than 1, that means it's getting bigger. And what can you tell me about a reduction?
One has to be less than 1.
Has to be less than 1. Is there a spot where it stops, though? 0. So scale factor for a reduction has to be between 0 and 1. Okay? So just be aware of that. Now when you are doing a scale factor, the nice thing is they're going to give you the numbers. You just have to decide how you're going to set up your fraction. Okay? I know that in this case I started at 4, and when I moved it I got to 13, correct? Which we said is an enlargement. Okay? So which one of those numbers is going to have to be the numerator or the top in my scale factor to be an enlargement?
13. 4.
Okay, let's check. Let's say I'd say 4 over 13. Okay? We just decided that to be an enlargement, my scale factor has to be bigger than 1, right?
So
Is this
13 over
bigger than
4.
1? No. So even if you do make a mistake, should it be easy to check?
Yeah.
Yeah. If you're telling me it's getting bigger, this needs to be bigger than 1, is it?
No.
No, so the correct scale factor would be 13 over 4. Is that bigger than 1 like we said it needs to
Yes.
be? Yes. Okay. So if I were to switch these, now it's a reduction, right?
Yeah.
My scale factor now would be 4 over 13. Okay. So they're going to give you the numbers needed. You just have to decide which one goes on top, which one goes on bottom. Okay? Based on these rules. To be an enlargement, it's got to be bigger than 1. To be a reduction, it's got to be between 0 and 1. Okay? Now, I'm going to use this exact same diagram here. I'm just going to move it down. Okay. So my scale factor is currently 4 over 13, right? Okay. What or how do I solve a problem where they give me this. They give me, let's say they say that this is 2. They want to know what is that length. Am I going to have to use my scale factor?
Yes.
Somehow. Okay? We currently said my scale factor is 4 over 13 right now, correct? Okay. But as I look at this, I already know the small one, and I'm trying to find the big one, right? If I multiply by this, is it going to give me a bigger number? No. Okay, so you have to kind of understand what you're looking at, okay? Because I know if I take 2 and multiply it times this, it's going to get smaller, right? But I want it to get bigger. So what fraction am I going to have to use?
13 over 4.
13 over 4. Okay, so you're going to use either the reduction or enlargement version of your scale factor. You just have to decide which one based on the information given to you. Okay? So when I do this, 2 times 13 is
26.
26 over
8. Or sorry,
4. Because remember, this is 2 over 1, right? Okay. Should I reduce my answers? Yeah. Remember, the only time I ever told you not to was on that one problem, right? Otherwise, we always reduce. What's this reduce to?
6.5.
Reduce it. Leave it as a fraction.
6 and 2 half.
Leave it as an improper fraction.
6 1/2.
Improper.
6 over.
Just reduce it. Take a 2 out of both.
13 over 2.
13 over 2. Okay? Don't worry about, you're right. Okay, Dylan, you're not wrong. But just leave it as an improper fraction. Because if we had to go back and multiply it later, it's a lot easier to multiply improper fractions than if you were to say like 6 and 1/2. If I had to multiply it by 7 or something like that, it'd be a lot easier to multiply this by 7. Okay? So you're going to use your scale factor no matter what. You just have to decide which version of it. Am I using the reduction or the enlargement? Okay, so you'll have 2 parts to each question. Now, what would have happened if you accidentally multiplied by the wrong thing? Should you be able to recognize that you're saying this bigger side is smaller than this? Yeah. I don't know what the answer would have been, but let's say it would have been like 0.75, 3/4. Okay, well, obviously, if that's bigger, it can't be 3/4 if this is 2, right? Okay, so just use some logic. Make sure your answers are making sense. Okay? On a coordinate plane, if I remember right, on your explorations, you did some on coordinate planes, right? Remember that? What do you have to do to the coordinate?
It doubles or it like.
You either multiply it by 2, or like say if it was dilation by a scale factor of 2, you multiply it by like 2.
Right, and which is, I think, what you guys did, right? I think it was a scale factor of 2 on your explorations. Okay, so just like you're saying, if it's a scale factor of 2, you need to multiply everything by 2, right?
Mm-hmm.
Okay, so if I have this triangle here at 2, 1, 4, 1, and 5, 4. This point, 2, 1, if I'm using a scale factor of 2, is going to end up where?
It's going to end up
2 and 1 is going to end up at
4
4, 2. And I multiply both of them. This one's 4, 1. It's going to end up at
2.
8, 2. And 5, 4 is going to end up at
10,
8. Okay. What was our center of dilation that we used there?
0.
The origin. I cannot think of a time in what we're doing where if you're doing a coordinate plane, where the center of dilation is not the origin. Okay? Every problem I can think of, the center of dilation is always the origin. Okay, so don't worry about that too much. Did every side length on that triangle double?
Yeah.
Yes. Even if we didn't do distance formula, so I don't know my two slanted sides, but they did because my scale factor is 2. It's 2 times bigger. Okay. Since we used the origin, notice that triangle not only doubled in size, but also got further away from the origin, right? It's now twice as far away from the origin as it used to be. Okay. Is it possible to have a negative scale factor?
No. Because it's less than 0.
It is less than 0. So what they're actually doing, it is possible, but what they are doing with a negative scale factor is you are making it, in this case, you're making it 1/3 of the size, but then you're also putting a negative sign on the x and y values, so you're actually reflecting it in the x-axis and the y-axis. Does that make sense?
Yeah.
Okay, so we'll do one here. They give me the coordinate points. Where did 3, 6, 3, 6, 6, 6, and 3, -3. Okay. So based on what I just told you, if these are both positive, and we're going to multiply both of them by a negative, they should end up down here in quadrant 3, right?
Yeah.
Where should this point end up at?
In
Quadrant 2. Okay? So, this is what I want you to be careful of, because last period, which would have been 3rd period, they struggled because they didn't want to write these out, and they were just trying to do it all in their head, and they were getting incorrect answers. Okay, so just be careful. Don't be afraid to write something out if you get it wrong the first time. I need 3 times -1/3.
It's going to be a negative
1,
It's going to
2,
be -1. 6 times -1/3.
3.
-2. And then I have 6, 6. 6 times -1/3 is
3.
-2.
-2. And the next one's going to be the same. And then I have 3, -3. 3 times -1/3 is -1. And -3 times -1/3 is +1. So now I did this work. I showed my transformation. Now I'm going to graph it. -1, -2. -2, -2, and -1, 1. Okay. Okay, so it is possible to have a negative scale factor. It's just going to change what side of the axis everything is on, x or y axis. So, can you sit up, please? Okay. Any questions on that one? Good? Yeah, that's okay.
Sorry, I can.
Good?
Yeah.
Okay. Alright, the last thing I want to talk about here is, I believe it's example 5. What they're doing is they're taking a picture or a photo, and it's currently 4 inches by 4 inches, and they're trying to reduce the size so they can put it on a 1.1 inch by 1.1 inch sticker. What's that? And you got to figure out the scale factor. First of all, reduction or enlargement? Reduction. Okay, if I were taking the picture and putting it on a big old poster, it would be an enlargement. Okay, so for a reduction, just like we did at the very first problem, they're going to give you the numbers you need. Okay, so I know that I'm taking this 4 inches and turning it into 1.1, right? what would my scale factor be? I'm obviously using those two numbers, right? We just gotta figure out which one goes on top.
No.
Yeah, it'd be
1.1.
The 1.1 needs to go on top because I'm reducing it, making it smaller, right? And 1.1 over 4 is very close to 1/4, correct?
Yes.
Okay, now have you ever seen a fraction written with a decimal in the numerator or denominator?
No.
How do I get rid of the decimal but still have the exact same or have an equivalent fraction?
You could
Do what?
put a 0 on the 4 and just move the decimal to the right.
I would do it how Jersey's saying. She's saying put this as 4.0. Now I have one decimal place on both of them, correct? And if I move the decimal one spot on both, which would be the same as multiplying by 10, right?
Mm-hmm.
Is that going to give me an equivalent fraction?
Yeah.
Yes. So now my fraction would actually be 11 over
Yeah,
40.
I've actually done that just like a long time ago.
Yeah, it's been like maybe like 4th grade, right?
Yeah.
Hey, we haven't done that for a long time. Okay. So then, if they would have given me, I don't know, maybe they say there's a tree in here, beautiful red tree, and they say it's, in this picture, it's 2 inches tall. Should you be able to multiply by this scale factor and tell me how big it's going to be in the sticker? Yeah. See? So it'd be what, 2 times, so it'd be 22 over 40, which would be 11 over 20. So our deer tree over here would be 11 over 20 inches. Okay. If you come across questions in your assignment, make sure you ask. You have plenty of time here to work today. So utilize that, take advantage of that, and ask questions if you have them. Okay?